Good morning, everyone. So thanks for the opening for the conference. I'm looking forward to this conference, and they scheduled me first. And I would like to talk about maximizing dependencies with interdependent teams. And let me first clarify this title a little bit, and then kind of the goal of this talk. One of the things that I guess most of the Agile community promotes is the idea of independent teams that can work isolated from the rest of the organization, so they don't have to interact too much or be blocked by other groups. And also myself, for years I thought that sounds really cool, right? Being in a team, focusing on the things that your team is doing, not having to interact too much with other teams. But this, like a lot of things in less, for me, kind of came as a surprise when I realized that it's not the right way to go. It's to me now wrong advice. You don't really want independent teams. Instead, you want interdependent teams, and also you don't want to avoid the dependencies between teams, but, and I know this is a little bit more on the on purpose controversy, you want to actually maximize those dependencies between teams. So I'll be explaining, what I mean with these two, why you would want to have that, and what kind of structures we put in place to kind of enable that. Now, this talk, I'm going to start with storytelling. It's something I started doing a couple of years ago. I found that storytelling is very powerful. But one of the problems of stories is that each separate story kind of just focuses on one point. So I started experimenting with something completely new. And that is, the story I'm going to share is actually a made-up story. Of kind of like the combination of all of my own stories together into a story that, all of the elements are part of a story, but that it's never together, and also the people never look like this. I started experimenting with using Lego minifigures as actors at my story, because taking 25 real people to act this out was a bit too much work. They don't listen so well compared to minifigures. So therefore, I'm going to start with about 10 minutes talking about some of the dynamics that a typical less teams are going through, using Lego minifigures, using these 5 teams. And then after that, I'll be explaining what they did and why, and how that then relates to maximizing dependencies with interdependent teams. So we have here one product with 5 teams, and I've tried to make the people look like it's obvious which team they're in. So you'll need to pay attention. The team criminals all look kind of mean. The team power all have uniforms. The team lake all have bathing suits. I discovered the hard part is distinguishing the space and the Halloween team. But the space people look kind of like they come from outer space, and the Halloween people are dressed up like Halloween. You need to look at those, because one of the things I try to do is show kind of the cross-team interaction, so you'll need to recognize which teams they're in. And these 5 teams are working on a product, a similar product I've worked on for a while, related to schools, university, course management systems. And the top of the product backlog I put here. Now, there's something important about the way I phrased this top of the product backlog, which is common. Right? In a less adoption, we have multiple teams working on the same product, But often they work, there's kind of large features or large themes that the teams will work on for a longer period of time. And they tend to be in the product backlog kind of integrated. So if you look at this product backlog, you'll see there's a couple of features related to direct registration to particular courses. And then there's a couple of features related to the integration of the scheduler. And then there's a couple of features related to the migration to a new technology. Right? And these are kind of the three large themes that are ongoing in parallel in this product. And therefore, the items, the large items are split into smaller customer-centric items. And the priority of those is kind of mixed. That's quite normal for a less adoption. Now, what we're going to do next is going to look at these 5 teams and go through the different less events. This was a lot of fun. I invited my son to do this also, and his patience was 5 minutes. So eventually I was the only one doing all these Lego figures. But this is the first event that we have in a sprint, the Sprint Planning 1. And Sprint Planning 1, which you see over here, is actually at least one of my favorite events. And I think it actually says a lot about how we work in less, and especially related to this. Now, what you see here is a large table. The white things on the table are the product backlog items. So we use a technique here, which in less we call put the cards on the table, which you actually take the backlog items and you physically put them on a table in order. Now, then you see the 5 teams standing around this table. But what you see is that, if you by now recognize all of the people which team they belong to, but there's 5 people standing next to the table, and those are the representatives of the particular teams, and they're having a conversation. And the conversation they're having is about which team is going to work on which items, and how are the teams going to help each other out. And so basically the teams got this list of stuff, it's here on the table, and now they're having a conversation about who's going to work on what and how to help each other out. Now you also see that behind the representative is the rest of the team, and they're having kind of within their group a bit of a conversation about what's happening. They're also informing their representative, and there's also some cross-group interaction between the rest of that. It's kind of happening in the background, where the foreground is happening around the table with the cards on the table. Now, one of the things that a good less adoption does is the teams that are standing there will purposely select related items in different teams. And let me repeat that. They purposely select related items in different teams. So even though we have 3 large themes in the backlog, the direct registration to a course, the external scheduler, and the upgrade to new technology, what in my experience, more experienced less adoption does is they will not try to have one team do the direct course registration, another team do the upgrade, and a third team do the external scheduler, which is what sounds like a logical choice. But instead, they're going to each team pick an item related to the course registration, one item related to the external scheduler, and one item related to the upgrade of the new technology. So that all of the teams are actually working on the same thing during the same sprint. And that's one key message of this talk also, and I'm going to get back to that, and also why they're doing that. So after the teams here, this event usually lasts about 30 minutes or so. It's not very hard. But the effect of this event is that after that, each of the teams have their items they're going to do, and also they have an idea of which other team is going to help them out and how, because those are kind of the main topics you talk about in Sprint Planning 1. Then after that, you start Sprint Planning 2, and one of the first sessions you're going to do there often is some kind of short shared design session. So that's what we see here. We see a large whiteboard, and then all of the team members of all of the teams standing around that, some of them towards the back chatting with each other, and then a couple of people towards the front. And one of the goals of this short session, and during the conference I believe Terry and Craig are going to also talk a little bit about how to do similar sessions to these. One of the goals of these sessions is for the teams to figure out for the items that they've selected, where in the design and architecture do they have connecting points? Where are they going to change the same components, the same classes, etc., etc., etc. However, it is not a session where you're going to flesh out all of the design. So usually it also doesn't take much longer than about 30 minutes. So it's just interactive in front of the whiteboard, talking about the items we picked up, looking at the existing architecture of our system, and trying to figure out where the overlap is between the teams. After the teams have done that, they'll end up in what in less we refer to as a multi-team sprint planning 2, and that's what you'll see here happening. You see the table from sprint planning 1, it's still there because usually it just happens after each other in a row. You see that each team has their own whiteboard area which they're having a conversation. So this is in a way exactly the same as in Scrum. They have their own Sprint Planning 2 meeting. However, they're in the same space, and because they're in the same space, they will be interacting with each other. So if you look, there's a couple of people screaming to each other or talking to each other. Over here, you have one of the teams that actually grabbed a computer and they're just looking at, for example, some code or whatever they need to look at to figure out what they're going to do. Oh, by the way, in all of these, you see the guy with the red hat and the coffee mug. That's, of course, the product owner. And that's a key point also, that in Sprint Planning 1, I didn't stress that, but I do want to stress that. You see that the interaction here is a team-team interaction, not a product owner-team interaction. The product owner put the cards on the table, and in a way, that's it. The product owner is done. So the product owner is sitting in the back drinking coffee, while the main thing on Sprint Planning 1 is the teams talking to each other on how they're going to do that. And likewise, in Sprint Planning 2, we find the product owner over there. He's there available to help out with priorities or vision, but he's not directly involved in any of the team's design and splitting of the work. Then the last event, or actually not this one, what you see here is an office space, and this is the kind of office space I've worked in less adoptions, and the one that I've started enjoying most also. And what we see here is that each of the teams, they actually have their own table, and they're working on their own table. They have their own whiteboards and sprint backlog and all of the things they need around that. But one of the things you'll see is that everyone is working together. There's no people working alone. People are pairing all the time. And also a lot of the pairing is done cross-team. It's not limited to your team because you have items that are very closely related. Therefore, it's very common for one person from one team to pair up with somebody from another team. So what starts happening is that these 5 teams, they start to work almost like one team. And they still have their own goal within their sprint and their own items. They'll have their own daily, they have their own identity, their own jokes, their own sprint backlog, etc. But in the day-to-day interaction, it becomes really hard to see who's actually working in what team because of that very close collaboration between those teams. And setting up office spaces like this enables that. Of course, if you have virtual work-from-home teams, it becomes harder. But one common decision in such a case is whether you use like one Miro board versus separate Miro boards. And then usually, from a less perspective, you prefer one because we don't want to isolate the work of the team with the other teams. Instead, we want to have that frequent interaction. And then the last, or actually the first event, and one of the most important one from a less perspective, is a multi-team product backlog refinement. So that's what we see here. And a multi-team product backlog refinement starts off with, remember we have the product owner there, and he's projecting the product backlog. And from that, we take on the different items that need to be refined, clarified, split, or estimated. And we'll form what in less we refer to as mixed up groups around those items. So if we look now, compared to the sprint planning at the teams around the whiteboards, then we'll see that from each of the teams, there's at least one person within those mixed up groups. Not exactly one, because the teams are not of exactly the same size. So sometimes you see more power team people within a discussion, etc. But at least one person is within each of these mixed up groups. They'll have their independent conversations about certain items to clarify that. Usually that works in, say, 30-minute-ish cycles. Then we'll have a way to merge the knowledge of the different groups, and then we'll start another 30-minute cycle. And usually we'll mix up the groups a little bit between these different cycles. And one of the effects of this is that all of the team members get to know their team and all of the other team members really well. They get to know all of the items in a product backlog. And for each of the items at the top of the product backlog, there was at least one team who was involved in the detailed clarification of that particular item. So far, the brief story, it should have been 10 minutes, about 10 minutes. The brief stories of and what I would look at as the way eventually I'd like to see a less adoption. And let me clarify the eventually a little bit, as I'll talk with the enablers also. When you start off, it will not look like this, because it takes some work to get the teams used to that, to get used to these events, etc. But after a while, it becomes almost second nature. There's not much to do anymore as coach or scrum master, and they'll just figure it out themselves. So what do you need to do to enable this, and why do you want to do this? And that's about the rest of the talk. And before I dive a bit in some of the principles, I want to point out what I now often refer to as the 2 journeys that a team often needs to go through in a less adoption. So what is, over the years, I noticed there's kind of 2 changes that the team needs to go to, changes in their perspective, changes in their behavior, and they've been virtually the same for every team I worked with. Right? And the first one is kind of the same as in Scrum also, which is the being told how you're working to becoming a self-managing team and making your own decisions on how you're working. Right? One of my favorite moments in almost all less adoptions is when you work with a team and the team starts figuring out themselves on how to work. Right? The team decided how they want to do the refinement. The team decided how they want to do the planning, how they work across the teams. But once they start doing that, they still complain about that. And that's amusing to me because this is what happened when they were told how to work. When somebody tells them how to work, they feel it's annoying and they start complaining about that. But then you remove that and you move the responsibility of deciding how to work in the team themselves. But often the teams are not got rid of the habit of complaining about that yet, but they're not yet realizing that they're the ones who can make that change directly. So therefore, as a coach, then a common theme is where the team comes to you and says, we don't like that. And then the answer is, well, then why did you do that? And then they realize that it's within their own control to actually change that. So when that happens, you know the team is kind of halfway this journey. But the harder one for many teams is what I refer to as from programmer to product developer. And from programmer to product developer means that as a programmer, you just expect somebody to tell you what you need to build. You expect somebody to give you the specification, give you the requirements, and you consider that your job is simply taking the specifications and building the system, programming the system. And almost all traditional teams are there. In fact, when you have a product owner per team or a business analyst, then you're nearly per definition in that, because teams who have these roles will always rely on somebody else to clarify the requirements for them and then tell them what to do. And again, that's not what we want to have in less. Instead, we, just like the previous one, we want to grow the responsibility of the entire team. And instead, we want the team members to consider that they are the experts in technology, and your customer is the experts in their customer domain, and they have certain problems to solve. And product development means that you combine your knowledge of technology together with an understanding of your customer and customer's domain, customer's problems to solve, and together you'll decide how to do that best. So products are not built by listening to someone giving you the requirements, but they're built by teams and customers collaborating and discovering the requirements, discovering what are the best solutions for the problem that the customer has and is trying to solve. These two journeys are very important. They typically, in my experience, take about 6 months per team or so before they make that shift in thinking, and it's important to look at. Now let's go back to the events, how and why they work. And I'll start off with some of the less principles and gradually move to more of the practices side. And one of the less principles is the whole product focus principle. And that's something you saw over and over within the events. And one of the most important one is having one product backlog for your entire product, so that the teams don't know what they're going to do the next sprint yet. They know they're working on this one product, and all of the teams work off that same backlog, but they don't know what their focus area is yet. And then in the backlog refinement that you saw earlier, each of the teams had at least one person involved in the clarification of each of the items. Again, that leads to this whole product focus. Now, I put a slide behind this slide because one of the interesting things about the whole product focus principle is that it also strongly relates to the second journey. Because one of the things that often happens in beginning-less adoptions, if you do backlog refinement, the way I just described it, then team members are going to wonder, why would I be involved in clarifying an item that I'm not actually going to work on? Right? It feels like inefficient and wasteful to do that. But that's the difference between a programming team and a product development team. Because if you just look at your job as coding the requirements, then it would be ineffective, of course, to clarify items that you're not actually going to build yourself. But if you consider your job as a product development, and the product, of course, is the whole product, then that means that in order to be better at your work, you need to understand the product from a very broad perspective. And the purpose of clarifying the items then isn't purely for building that. It might be, because you might be the team that is going to do that. But it is more for the purpose of learning more about your product, learning more about your domain, your customers' problems, etc. And that much broader product knowledge, this whole product focus, helps in the future with being able to understand why your customers are requesting certain features. Or even better, your customers simply giving you the problems, describing the problems that they have, or you discovering the problems that they have, and the teams themselves coming up with the features that will help solve your customers' problems. Right? That is product development. And in order to do that, you need to have that whole product focus. And then, somewhat related, but a different perspective, is the teams need to be customer-centric. They need to understand customer domain. They need to understand what they're doing, how that relates to your customer. Now, one of the big concepts in less that enables the kind of working that I just described is the change from component to feature teams. And I'm not going to give a very long description of that. I hope most of you are familiar with that. But it is typically one of the two changes that one of the two immediate changes that an organization goes through when adopting less. And in case you're curious, the two changes are moving from component to feature teams and removing the product owner per team. Those are the two most common changes, the most common immediate changes once you start adopting less. Now, very brief, component teams, which is the traditional structure in which most organizations are working, we have the team structure mapped to the architectural structure. So teams own a part of the system. So we have component team A owning component A, component team B owning component B, etc. They're very easy to recognize, but one of the techniques I nowadays use is simply listening to the name of the team. Whenever the name of a team is associated to something that they do, then you have component teams. Right? Whereas in a feature team, teams also tend to have names, but the names tend to be power and space and things like that. And clearly the power team is not working on power, They just happen to like that name. So whenever the team name is related to what they're doing, you'll likely have component teams. It's super easy that way to discover that. Now, there's a lot of problems with this structure, but the problem that is most relevant for this talk is that it leads to dependencies between the teams, because customers don't ask for component functionality, of course, with the rare exception when you're selling components. So they will not ask for component functionality. Instead, they ask for customer-centric features. And customers don't look at your architecture, and therefore there's no mapping. No matter how good your architecture is, there will not be a mapping between customer requests and the changes in the components. And therefore, in order to actually build end-to-end functionality with a component team structure, you will have dependencies between the different teams. So in less, we adopt the idea of feature teams. And just to be clear, because sometimes this happens, a feature team is not a team structured around one particular feature, but it's a team that we are basically constantly giving customer problems to solve, and after they solved one problem, we'll give them a new one. And then after they solve that, we give them a new one, but we don't break up the teams. So in this case, in the product backlog, there's 3-4 items, problems to solve, and they're just given to one team. And that one team can work on that customer-centric problem without having dependencies to the other teams. Now, obviously, that's not completely true, because the big difference now is that the teams potentially work across the system. And I'm going to get back to that still. Potentially, they work across the whole system, so therefore the teams might work within the same components. Now, there's something very different between the dependencies of component teams and the dependencies of feature teams. And there, again, by lack of terminology, I've started to call these asynchronous dependencies versus synchronous dependencies. Now, what does that mean? If we look at the component team dynamic here, then if you look at the way this picture is drawn, then the component A team will work on item 1 during the next sprint, because on the product backlog, item 1 is of the highest priority. But component team C, from their perspective, item 4 is of the highest priority, so therefore they're going to work on item 4. However, item 4 also requires work from team A, but team A isn't going to work on that because from their perspective, it isn't the highest priority. So what happens now is that team C will work on item 4 the next sprint, but they can't complete the entire feature without the work from team A. But team A will not work on it at the same time. Instead, a couple of sprints later, team A will work on that. And of course, they'll try to integrate their work with what team C has been doing a couple of sprints earlier, and that will not work. And then team A will start interrupting team C because they need their help to get it to work. And team C will be annoyed by this interruption because they're working on something else right now. Right? So what is happening in this kind of dependencies is that they're not happening at the same time. And when dependencies between teams are not happening at the same time, the dependencies become annoying and cause interrupts. Whereas if we look at the other side, they also have dependencies between the teams, but these always happen at the same time. So I refer to these as synchronous dependencies. So whenever team Y needs to change component A, they'll only have a dependency when team Shu also needs to change component A at the same time. If team Y changes it in sprint 1 and team Shu changes it in sprint 3, then they have no dependencies between each other. Right? So now, because the dependencies are what I then refer to as synchronous dependencies, suddenly it becomes a benefit for the teams to actually collaborate with each other. The dependencies are not anymore an interrupt, but they're an opportunity for cross-team interaction and collaboration. So when referring to interdependent teams, we're looking for teams that are not independent and isolated. We don't want them to be independent and isolated because they're working on the same product. They're solving the same customer problems within that same product. So if we're isolating them, then your product will look like a couple of bolt-together components that are likely not functioning very well together. And we don't want that. And instead, we want the teams to have this whole product focus. And in order to have that whole product focus, we'll need to focus on cross-team shared learning. All of the teams need to know about the other teams because they have the same goal of that same product. So isolating them would be a terrible mistake. Now, if we build onto that and build onto the synchronous and asynchronous dependencies, another way of thinking about dependencies is that there's two types of dependencies. In English, we use dependencies for both of those. And the first one is the literally meaning of dependency, which means you're depending on the other team. Right? In other words, you can't proceed until the other team has done something. You'll be blocked by the other team till that team has done their part of the work. And that's actually the big problem. Right? When people say we want independent teams, they don't actually want independent teams. They want non-blocking dependencies. They don't want to have to stop and have to wait for another team to finish their feature. However, we also use the phrase dependency for another kind of dependency, and that's what in less we like to call shared work. And that's what we already saw in the sprint planning, where the teams were purposely selecting very closely related items. What they were doing by doing that is they're actually maximizing the shared work between the teams. Right? So whenever I refer to as maximizing dependencies, then I do not mean maximizing the blocking dependencies so that teams get super annoyed, but instead I would refer to maximizing the amount of shared work across the teams, because the more shared work they have, the more cross-team shared learning there will be. Right? And that's kind of what the teams start also enjoying. They start enjoying to work together within the same sprint across multiple teams. Now, another aspect of feature teams that I think we often overlook, but that is super powerful, is when working in feature teams as a team, you have much more choice. Because as a component team, whatever work comes for your component automatically goes to your team. So in a way, you have no choice on what to do. But once you work in a feature team organization, what happens, this was the sprint planning 1 dynamic, what happens is that the teams actually get to choose what they'll work on. Of course, within the boundary of that they need to together work on the top of the product backlog. So this additional choice is very nice for teams. It gives some more learning and much more flexibility on choosing the things that you'd like to work on. Right? Now I've got an example here. Let me start off with the example picture. This is actually taken from a team that I've been working with for about 1.5 years, the last 1.5 years. The team I worked in was Team Hub. I worked there as a developer. And one of the things the Hub team did is they defined the kind of work they like. Right? So they said, we like features that are complex and touch most components. We don't want to work on one component. That is boring to us. We want to touch the features that are across most of the components. Those are the most interesting for us. Then this was an university management system. So the other thing they said is, we like features coming from students. We don't like the admin type features. We like the student features. And then related to that, we like working on the UI. Right? So therefore, the team basically, as a team, looked at what are the type of things they like to do. And then in Sprint Planning 1, they use this. They use the idea of trying to maximize shared work. And they'll have a collaboration with the other teams about what they would want to do. At least that's how they should work. This team didn't work that way particularly, but that's a longer story. Now, one of the other things that happens here is the concept of accidental specialization. And this is super important and makes a lot of this scalable to virtually any size. And you see that also here, which is they like working on features that have a graphical UI. And because of that, part of this system was an app. And my team liked working on the app. So whenever there were very heavy UI features, we tended to pick those up. We're not the only team that works on the app, but because of our interest, we took on the more complex and the harder app features. The side effect of that was that within the organization, we were still sometimes referred to as the app team. Not because we only worked on the app, because we didn't. Not because we owned the app and were the only ones that made changes in there, because we didn't, but simply because we had the most amount of knowledge of that particular component. We were accidentally specialized within that particular component. Let me make a comment to Chris, who's annoying me about the time. Can you put it to 10 more minutes? It's going to take 10 more minutes. Now, this accidental specialization is really important, especially because if you have 5 teams, then in most systems, all 5 teams can work relatively comfortable on all parts of the system. But once you have 100 teams, that doesn't become realistic anymore. But because the teams have their own preferences and they accidentally start specializing in part of the system, therefore, it scales up to virtually any size, but because there will be parts of the system that the team will simply never work on because the types of features that they pick up are just not the ones that touches that part of the system. Now, one of the other less principles, large-scale Scrum, is Scrum, and this is often about trying to see whether the cross-team dynamics in less are similar to the in-team dynamics in Scrum, right? So if you think about it, in a typical Scrum team, you also have accidental specialization, because you pick up the top of the backlog and there will be items that I like doing because they're TypeScript items, and I like doing TypeScript items, so therefore I have preference towards that kind of work, and therefore I will accidentally specialize in that particular technology. That happens within a team, and unless the same thing happens cross teams. So the dynamic cross teams, you can often think about it as similar as the dynamics in teams. Now, and here again, in-team dynamic in Scrum, in well-working Scrum teams, they often maximize the amount of collaboration within the team with practices like pair or mob programming. And that's exactly what we're now doing and seeing cross-team, where cross-team, the teams are maximizing the amount of interaction across the team to maximize that learning and make work a lot nicer. One of the other things that is an effect of this is that you can work in larger one-piece flow, right? Because now, if a super important large feature arrives, you can actually work with 5 teams at the same time on the same larger feature. Traditionally, that wasn't really possible, and we would create projects for each of the larger features and typically assign individual teams to that. But once we start working on this, we don't need to do that anymore. We can simply take that larger chunk of work that is the highest priority and work across, for example, 5 teams on that. Now, one of the effects of working in feature teams is that you get shared code ownership. And a couple of conferences ago, Craig already made the link between shared code ownership and what in systems thinking is sometimes referred to as the commons, or a common resource that multiple people are affecting. And book recommendation, excellent book. In this book, they look at ways of managing the commons or avoiding the tragedy of the commons as 3 typical ways. Educate, so help people see the consequences of unrestrained use of the commons and appeal to their morality. Privatizing the commons, so divide it up and regulate the commons. Mutual coercion, mutually agreed on, standards and agreements across teams. Now, traditionally, the commons, the shared code, is almost only managed by privatizing the commons. And often organizations see that as the only way. But it's not. And one of the things that happens in less is that we shift away from privatizing the commons, which means we split it up and lead to team or individual code ownership, and instead we'll use educate and exhaust and regulate the commons as ways to prevent the commons, the shared code, from getting worse and worse over time. A key thing for being able to work this way is work in an incremental way. And almost all teams that I worked with had to learn this. And this is a very easy slide. This is a huge topic for virtually all teams that I worked in. For example, the team that I was in recently, they needed to do a large JavaScript framework upgrade, and they didn't believe that was possible to do incrementally. Eventually, over weeks and months, they learned how to do that, and now they see that it is possible. But if you would have met them 2 years ago, they would have said, there's no way, that is completely impossible to do that in an incremental way. And that is very, very common in teams when they start a less adoption. They need to learn this incremental change. I will have, on request of Craig, an open space session later on incrementally upgrading JavaScript frameworks for those interested. It will be technical.
Continuous integration is another practice that is super important because with continuous integration, we're continuously sharing the work with each other. Right? The team that I joined with a couple of years ago, when I joined, I started committing, pushing about 10 times a day. And my team got very angry at me because I did that. They said, I'm ruining the Git history. And we had to have a long conversation about that, where my team member once said, once you committed twice in the same minute, I don't understand how you can do that. Right? So it was very hard for them to learn this practice of continuously sharing the work with each other. Now they do. It took a while, but they've gradually learned to break up their work in smaller chunks and constantly integrate that with each other. Now, continuous integration is often seen as a technical practice, but it's very much a social practice because once you're continuously integrating the work with each other, it enables much closer collaboration between the people in the team or in the teams. Right? And that's one of the key things of continuous integration. Also, cross-team, it has the same effect. Whenever somebody in the other team is changing something, I will see that immediately. Right? And related, therefore, to that is the practice of communicating code, where you use continuous integration to discover what other team members and other teams are working on, and let that changes trigger the interaction across the teams. So here you see also a screenshot of the team I was working on, and you'll see that there's many commits per day in this particular component. But one of the things we did here is hook up the code repository with, unfortunately, Microsoft Teams, and then Teams would give this pop-up whenever somebody made a change. And then usually when it is in a place that I'm working, I would click on it immediately, and usually within like 1 minute after they committed, they would get a review comment suddenly from me about the commit that they did. So it's that tight and close collaboration that you want to look for in and cross teams. Therefore, do not branch. Another common practice that is important is looking for mono-repositories. So put all your code in the same repository. Don't put everything into separate repository, because putting it in separate repositories isolates it and it hides the changes from other teams. And that's exactly what we don't want to do. That is that isolation independent mindset. And we don't want that. We want this interdependent mindset. And technically, that means you probably want to move to mono repositories. So, to summarize what we talked about, in less, one of the things we want to do is maximize dependencies, which means maximize the shared work across the different teams, not try to isolate the teams. Within the interdependent teams, teams that don't work on their part, but teams that work together with the other teams all the time because they enjoy it. It doesn't cause blocking. It doesn't cause frustration. Instead, it causes learning and collaboration. So why wouldn't you want to do that? So this is one of the big changes that we're going to in less. And according to Chris, I have exactly 47 minutes in my time box now. I'm going to finish that, but I do want to add one thing, just a recommendation. Not too long ago, the Software Engineering at Google book was published, and especially related to this technical practices side. It's excellent and describes a lot of the things that we often try to achieve also in less. Also, the site reliability engineering book is great. And with that, thank you very much.
and have a great conference.
One of the things I see over and over again at clients with a lot of junior developers, because they grew and they hired a lot, is that the developers' brains explode. So this isolation, there's a strong wish for more isolation so people can be, like at least understand part of the system well enough to not cause damage. And I'm having trouble introducing these ideas with those teams. And I saw it at different clients, so I'm thinking I'm maybe missing a point, and I'm asking for the point that I'm not seeing.
So what was the question?
If you try to bring everyone, like to understand every backlog item, the mental overload goes up for people to the point where they are but they're constantly just swimming, they're drowning in things they don't really understand and doing bad code. So how can I avoid that? It seems like if I have my component, at least I understand my component.
Let me try to answer that, because the first part of your question and the second part of your question didn't actually relate to each other.
Okay.
Let me clarify that first, because we want all of the teams to be involved in all of the items, but that relates to understanding your customer domain, doesn't relate to understanding your code. So if you make the comment, if all of the teams will be knowing all of the items, then their brain will explode because that part of the code they can't work. That's a mismatch.
Okay.
But let me start off with the first one, because my experience is very different, which is once you only see part of the larger product, it's actually harder to work than once you have that larger view of your product and understand much better what your customers are trying to achieve. So I've not experienced that mental load, although for teams that begin to work that way, the starting point of the refinements, there's a lot of different learning. Now, related to your second point, having worked a lot with more junior developers, one of the key things that you want to focus on is how they work. Because often they work in my experience, they work in a style that avoids learning. And if they change their working style slightly, then often their learning and pleasure in their work is much higher. To make that concrete, one of the things I noticed is more junior developers often stop when the feature works, rather than when they understand their solution. And if you teach people that whenever you build a feature and it happens to work, but you're not quite sure yet why or how, and instead spend that 2-3 hours longer to truly understand how it's working, then the learning increases dramatically in teams, and I've not experienced what you're describing. That said, I do want to point out that especially this dynamic of accidental specialization ensures that rarely do teams ever need to know everything. So, for example, in the team I worked with, I loved going everywhere over the system. So whenever I have this tiny change, which is in a system that nobody had ever worked on, typically I would be like, me, let me do that. That sounds like fun. And one of my colleagues said, I already have trouble understanding the component we frequently work, so I prefer not to do that. So therefore, within the team, she tended to pick up the work that was more comfortable, and
limited the learning to her learning capability at that point in time, whereas I guess more experienced, would go all the way to the system and had lots of fun doing so.